Alright, so in this one let's discuss about routing. Okay, so when it comes to routing, first we have to identify what is routing, right? So routing is the process of selecting a path across multiple networks, because when we are connected to the internet, we are not the only one using internet, right? There are multiple people using internet. So internet is a collection of networks. So if you are going from one network to another, which is located in far away from our current location, that means we have to pass different kind of networks just to get to the destination. So routing is the process of selecting the best path across one or more networks. Okay, so in packet switching networks such as internet, routing selects the path for internet protocol packets to travel from their origin to their destination. Okay, so we are using IP packets in the internet, so those IP packets should be travels from source to the destination. So routing is the process of doing that. Okay, so these internet routing decisions are made by specialized pieces of network hardware called, it is router, right? So router is the one who's responsible for routing these packets. So what layer this router works actually? So router is working on the layer 3. That means it is working on the network layer. That's why it is working with packets, right? So because within the network layer we have IP, we are adding the IP headers, right? So these routers actually works on that layer, that means the layer 3. So if we say a layer 3 device, usually these layer 3 devices are capable of routing. We have layer 3 switches as well, so those switches are capable of routing as well. So usually in this case for the labs, I'm going to use a router, not a layer 3 switch. Okay, all right, so how does routing work then? Okay, so the thing is, routers use a routing table to decide the most suitable route. Okay, so when a router receives a packet, it reads the headers of the packet to see its intended destination. That means when the router gets the packet, it's going to check the header, right, the IP header, and see what is the destination. Okay, then it determines where to route the packets based on information in its routing tables. In the routing tables, we might have for an example, we in the IP header we have 192.168.1.1, right? Then we have to figure out where is this subnet, or where is this network. In the routing table we might have that IP address, so we can figure out which interface we have to use to get into that network. Okay, so routing tables can be either static or dynamic. So we have two types of routing. First one is static and the second one is dynamic, right? In this case, in this lab, in this tutorial, I'll be working with static routing, right? Dynamic routing requires some protocols, and those protocols will do the dynamic part. So I'll give you some sort of idea what is dynamic routing in this video, but eventually you'll learn how dynamic routing works as well. So static routing tables do not change and should be configured manually. So usually the network administrator or some person who's responsible for managing these routers will have to manage the static routes. That means we have to do everything manually, right? That means it is very time consuming, and it is not efficient. Especially it is not efficient for very large networks, because if it is a large networks, if you are doing it manually, that means it will take maybe days, maybe week, maybe months, right? So dynamic routing tables updates automatically using various routing protocols. That means in the dynamic routing approach, what we are doing is we have implemented some protocols, some algorithms, and those protocols will learn the available routes by itself. That means we don't have to do a lot of work. So in that way it is somewhat efficient, right? Okay, so here's the thing. So dynamic routing requires more computing power. So it is efficient when it comes to creating the routing tables, but the devices require more computing power, because now everything's doing by the device itself, right? That means device have to do all the computations and figuring out all the paths and stuff. That means it requires some sort of a computation power, right? So because of that, dynamic routing is a little bit costly when it comes to this computation part, but otherwise it is like a very nice approach. And in the practical scenarios we always use dynamic routing because it is much more easier, right? So there are few protocols these are few protocols actually helping that to ensure that routing works. First one is IP, as I mentioned. So IP specifies origin and the destination for each packet. Routers inspects IP headers to identify where to send them. Okay. Then BGP. So this is a dynamic routing protocol. And announce which network control which IP addresses and which network connects to each other. So usually this is used in large networks, right? So large networks that uses these BGP announcements are known as autonomous systems. So if you Google search autonomous system, usually these within the large networks we use this BGP. I think it is a border gateway protocol. Okay, border gateway protocol. Then we have OSPF. So OSPF stands for Open Shortest Path First. As the name implies, it is finding the shortest path and determining the routes. So in this way, it is very fast and it is figuring out what is the shortest routes for sending packets. And with that information, it's going to create the routing table. Then the next one is RIP, and it is uses the hop count to find the shortest path. Okay, so these are few of the available dynamic routing protocols, and there are a lot of routing protocols as well. But in this lab, I'll be focusing on some static routes. Okay, not dynamic routing. Okay. All right. So I'll be moving to the lab. So this is the lab I'm planning to do, right? This is not a very complex one, and these are the IP address information. So 172 range subnet mask is 255.255.0.0. That means this is the one. Then we have 2.0.0.0. It is 255.0.0. Okay. So when we are working in the packet tracer, we'll figure out what are the IP addresses and what are the subnet masks for these each IP address. All right.